Welcome back to the Campbell Tech channel. My name is Sean Campbell, and today I'm going to show you how to implement the singleton design pattern in Java. The singleton design pattern is a creational design pattern that ensures that a class can only have a single instance, and it provides a global point of access anywhere in the application to that instance. It basically restricts the instantiation of a class to a single object, allowing that object to be easily accessible throughout the application. Okay, so now it's time to go ahead and implement our singleton pattern. Some common use cases of the singleton pattern includes using it for a logging system, in other words, to have a single instance of the logger. Other use cases includes using it for the database connection that your application connects to, so that there's one globally accessible method for obtaining the database connection. You can also use the singleton pattern to implement a configuration manager. You might want to have a single instance of the configuration manager to avoid reading the configuration from files or databases multiple times. You could also use the singleton pattern to implement a cache manager so that you have a single accessible instance containing certain cache that is accessible anywhere in the application. Now, we are going to keep it quite simple, so let's base our singleton example on a logging system. Now, there are several ways that you can actually implement the singleton pattern, including eager initialization, static block initialization, lazy initialization, ThreadSafe Singleton, and Bill Pugh Singleton implementation. Okay, so let's start with the eager initialization approach to implementing a singleton. Let's go ahead and create a new class, and let's call it eager initialized singleton logger. Okay, then with the eager initialization, the instance of the singleton class is created at the time that the class is loaded. Now, there is a drawback to this because eager initialization is created regardless of whether the client application might use it or not. So if you're not logging anything, for example, if you're only using your logging system to log exceptions and there are no exceptions while your application is running, then you have already initialized the singleton, although you might not need it. So with the eager initialized singleton approach, you will have a private static final field of the same type, eager initialized singleton logger, and then make sure that you call it instance. And then you can say equals new eager initialized logger. Right. And then you'll have a private constructor, and that is to make sure that client applications cannot use the constructor to create a new instance of the eager initialized singleton class. So we'll say private eager initialized singleton, and if you want to go ahead and make a note, you can say something like make sure clients can't use the constructor to create a new instance. Okay, and then you also need to go ahead and add a public static method. So let's say public static eager initialize singleton logger, and let's call it get instance, and it will simply return our single instance that is eagerly initialized. Okay, so that is the gist of it, but to go ahead and add some functionality, let's go ahead and add a method that will allow us to log an exception to the terminal. So we can simply say public void. Now this should be an instance method, and it'll be of that very one instance that we are initializing here, eagerly that is. So let's say public void log. Then we can say exception E, and that's all we're going to log. All right, we can simply say system.out.println and say e.getMessage. Okay, you might say, hang on, you don't just want to log exceptions, you also want to log other types of messages like strings. Let's have an overloaded method that takes in a string message, and again we'll simply print that out. Now this is very simple and trivial, I know, but it's just to keep the example extremely simple and to focus on the singleton pattern rather than on some sort of functionality. Okay, so that is all we need to do. All right, and we can also implement the singleton, like I mentioned, as a static block initialization. So let's go ahead and create another class. We can call it static block singleton logger. Okay, and then this time we'll have a private static field again, not final this time, and it will be of type static block singleton logger. Call it instance. That's a general standard for singletons, to call the field, the single instance that you're instantiating, instance. Okay, again, make sure that nobody can actually instantiate a new instance and bypass the entire singleton. Okay, and like I mentioned, you'll use a static block, so say static, and then we're going to say try, and then say instance equals new static block instance logger, and then catch. We can handle this exception. I'm simply going to throw a new runtime exception and say exception occurred in creating singleton instance. Exception occurred while creating singleton instance. Okay, right. And then we'll have another method, which is a public static method that returns the static block singleton logger. Again, we're going to call it get instance. Right, and then simply return the instance. So this is quite similar to the eager initialization approach, but this time the instance of the class is created in the static block, like so. Okay, so now the problem with both these approaches at the moment is, or the disadvantage rather, is that it gets instantiated even if you don't use it. And you might say, but you'll always use logging. But for the entire scope or runtime of an application, you might actually not have an exception, especially if it's a small application with a single purpose. Okay, so there's an issue here. Let's just make sure what's wrong. I forgot the semicolon there. Okay, so we need to go ahead and actually add our methods there again. Now, you might say, hang on, this is not nice to duplicate code, and I completely agree with you. So let's just go ahead and create an abstract class and just call it singleton base. You'll probably only have one specific implementation in your application, but to keep it nice and clean, let's actually go ahead and use this abstract class. So I'm going to go back here and remove those two methods and say extends singleton base. Same with the static block singleton logger. Okay. Right. Now there are more approaches to implementing a singleton method, like mentioned. So the next one is the lazy initialization approach. So let's create a new class again and call it lazy initialized Singleton logger. Okay, also extend the Singleton base. Okay. All right, so then the first thing we need to do is to go ahead and add our private static field for our lazy initialized Singleton logger, and then a private constructor like we did previously. So let's go to the static block Singleton logger. Go ahead and copy both there. And then let's change the type from static block Singleton logger to lazy initialize Singleton logger. Same with the private constructor. And then we need to go ahead and add our public static method that returns lazy initialized Singleton logger. Again, call it get instance. Then this time we're going to check if the instance has in fact been instantiated or not. So let's say instance. If it's null, then we are simply going to instantiate it. Else we'll simply return the already instantiated instance that has been instantiated. So this was the first Singleton implementation that I have ever known to implement, and it makes more sense if you see it in this way. So you're basically saying, well, you've got a field lazy initialize Singleton, a single instance, and in your get instance method you are saying if that instance is null, then instantiate it. So it will do it the first time. The next time it'll see it's not null, and then it'll simply return this instance. And then the private constructor makes sure that we can't actually instantiate it through the constructor. Okay, again, it's extending the Singleton base, so we will have access to the log methods. So we've now implemented 3 approaches for implementing the Singleton method. The next one is the ThreadSafe Singleton. So create a new class and call it ThreadSafe Singleton logger. Okay, so the ThreadSafe Singleton logger is actually going to look a lot like the lazy initialize Singleton logger. So let's copy everything here. All right, and then change the types. All right. Now the only difference here is we are going to add the synchronized keyword to our get instance method. So this is just a simple way to make sure that this Singleton class is thread safe, because the synchronized keyword will ensure that only one thread can execute this method at a single point in time. We must just remember to extend the Singleton base to have access to those log methods, and then we are going to implement the next one. So the next one is the Bill Pugh Singleton implementation. So create a new class, call it Bill Pugh Singleton logger. So prior to Java 5, the Java memory model had a lot of issues, and the previous approaches used to fail in certain scenarios where too many threads try to get the instance of a Singleton class simultaneously. So Bill Pugh came up with a different approach to create a Singleton class using an inner static helper class. So let's look at how this is done. So create your constructor, private Bill Singleton logger, private static class. This is the inner static helper class. Like I mentioned, call it Singleton helper. Right, and then simply say private static final Bill Pugh Singleton logger, call it instance equals new Bill Pugh Singleton logger, right? And then the public static method that returns Bill Pugh Singleton logger get instance, and then we'll return Singleton helper dot instance. Okay, so you might say, whoa, why does that actually help this problem? So notice that the private inner static class contains the instance of the Singleton class. When the Singleton class is loaded, the Singleton helper class is not loaded into memory. And only when someone calls the getInstance method will this class get loaded and create the Singleton instance. This is the most widely used approach for the Singleton class in Java, and in fact doesn't require synchronization. So well done, Bill Pugh. Okay, again, don't forget to extend the Singleton base. Okay, so now I have shown you 5 different ways to implement the Singleton design pattern. We can go and test this. Let's go to our static main method, and we can go ahead and say Singleton base. Remember to depend on abstractions and not concretions as per the dependency inversion principle. So let's call this Singleton logger, and then we can say equals eager initialize Singleton logger dot get instance. All right. Okay. Let's do a test to see if it's the same instance. So we can do 2 of them. Okay, so we have a Singleton logger 1 and a Singleton logger 2. So let's say here if Singleton logger 1 equals Singleton logger 2, then we'll print it out and say same instance, Singleton pattern correctly implemented. Okay, and we can also just do one of them, Singleton logger dot log, and I'm just going to log a message saying this is logged using a Singleton logger logging system. Okay, let's run it. There it says same instance, Singleton pattern correctly implemented, and then this is logged using a Singleton logging system. Now we can try it with the static block Singleton logger. Right. Now we can actually go ahead and add a breakpoint in the static block and see if it gets initialized even before we call it. So let's add a breakpoint there. We've got one in the static block. The same would have been true for the eager initialize Singleton logger. So let's go ahead and debug. Now you'll see there the get instance method was not yet invoked. There it gets invoked. So the static block always gets called first. So there it says Singleton logger at 426. And there's also at 426, so it's the same instance. So if we run it here, you'll see same instance, Singleton pattern correctly implemented. This is logged using a Singleton logging system. Now the lazy initialize Singleton pattern, we can put our breakpoint there and change this to lazy initialize singleton logger, both of them. Right. And then we can stop and rerun. There you'll see the instance is still null because we're not instantiating it prior to invoking get instance. Then it gets returned. All right. And then this time it'll hit the get instance method again on the singleton logger 2, but it will not instantiate it again. It will simply return that very same instance. Okay. And then this is logged using a singleton logging system, as you can see there. Okay, so the next one we can check, which will be similar to the lazy initialize singleton, is the ThreadSafe Singleton logger. Okay, and then I've already got a breakpoint there. Then we can check the instance is null. It gets instantiated. For singleton logger 2, it's already instantiated, and we simply return the instance. The same instance, single pattern is correctly implemented, and we log a message. Okay, and then the final one is the Bill Pugh Singleton logger. So we can actually add a breakpoint there and in there. And then we can change this to Bill Pugh Singleton logger. And let's go ahead and debug. So you'll see that it hasn't hit our singleton helper class until we access the instance. So there we have the 428. It returns the same instance. It is equal to each other. It's the same instance, single pattern correctly implemented. And again, we log our message. Okay, so as you can see, there are actually several ways that you can implement the singleton pattern. Please go ahead and comment in the comment section of this video what approach to implementing the singleton pattern you actually like the most and why. And if you've enjoyed this video and would like to see more of these types of videos, please subscribe to our channel and like this video. Till next time. Till next time.